All right, here we go with another question. This one comes from the 2018 AB exam. It's free response question number 2, which means this is a calculator active question. So get your graphing calculator, you're going to need it. All right, it says a particle moves along the x-axis with velocity given by v of t equals 10 sine 0.4 t squared divided by t squared minus t plus 3 for the time interval 0 less than or equal to t less than or equal to 3.5. Okay? The particle is at position x equals -5 at time t equals 0. In part A, they want me to find the acceleration of the particle at time t equals 3. Well, that shouldn't be too bad. For part A, I want the acceleration at t equals 3. The derivative relationship that we need to keep in mind is that acceleration is the derivative of the velocity. They gave me a velocity expression. We're going to need to find the derivative. We're going to need to evaluate the derivative at t equals 3. And that'll do it. There's no mention of units anywhere in this problem, so we're not going to worry about units down here. Not too bad. Seems pretty straightforward. Now here's the thing. I want to find the derivative of this expression up here. And some students are going to look at this and they're going to say, oh, well, that's a fraction. It's a quotient, so let's use the quotient rule. That's fine. You can do that. That's not a problem. But this is the calculator active portion of the test. It is foolish to do any calculus by hand that can be done on the calculator. So instead what I want to do on this problem is we're going to find the derivative of the velocity at time t equals 3 using the calculator. So you get out your calculator while I switch over to my calculator. There we go. And because I want to maximize the time that we have, I've already typed the function into my calculator in advance. So you take a moment, pause the video if necessary, get this graphed. Keep in mind, you cannot graph in terms of t, so we had to convert everything over to be in terms of x. Make sure you're in radian mode. Make sure that you have your calculator set to display three places after the decimal at all times. Okay, I'm going to assume you've gotten it graphed. So here is my velocity function. Now, this is from -10 to 10. The problem specifically said from the time interval 0 to 3.5. So let me change that. There's my graph. That's the correct function. And we want to find the value of the derivative at time t equals 3. Because I'm on the graphing screen, I'm going to go over to Menu. I'm going to go to Analyze Graph. I'm going to find my derivative, my dy dx. It asks for the position. The position is 3. And the value that I'm getting is -2.118. So write that down on your paper somewhere. What that means is I want to find, I gotta fix my notation here, at t equals 3. The acceleration at time t equals 3, which is the derivative of the velocity at time t equals 3, is -2.118. Because no units are given, we're not going to make up units in this problem. We're not going to make it meters per second squared. The College Board awarded 1 point for the answer, and that's all this question was worth. 1 little point. But not bad. A pretty easy point to pick up if you know how to use your graphing calculator. Let's move on to part B. In part B, find the position of the particle at time t equals 3. I want the position at t equals 3. Earlier in the problem, they told us that the position is x equals -5 at time t equals 0. So at t equals 0, position is -5. So I know the position at one time. I need to know the position at another time. What this is a fundamental theorem of calculus question, the FTC. The FTC says that f of b equals f of a plus the integral from a to b of f prime of x dx. Well, how does that help here? Usually the a value, that's going to be the value of the function that you know. We know the position of the particle at time t equals 0. I want the position, we normally use x for position. The position at time 3 is the position at time 0 plus the integral from 0 to 3 of the derivative of the position function at with respect to t. Sorry. Well, let's keep going. The position at time 3 is the position at time 0 plus the integral from 0 to 3. Well, the derivative of the position is your velocity function. So in order for me to solve this problem, to find the position at time 3, I take my position at time 0, which is -5, and I add on to it the integral from 0 to 3 v of t dt. Again, we want to keep in mind that this is a calculator active question. So to evaluate the definite integral, we're going to go back to the calculator. Now that we're back with the calculator, I want to do the calculation not on the graph screen, but I want to switch over to the calculate screen. I'm going to start with -5. Oops, my bad. I'm going to start with -5, and I'm going to add on to it the value of the integral. In order to do that on the calculate screen, we do menu, calculus, numerical integral, and now we just fill in the spots. The integral from 0 to 3 of, it's the velocity function, but on my calculator, that function is f1 of x. We integrate with respect to x. We hit enter. And my answer is -1.760. So write that down on your paper, -1.760. We're going to go back over to my notes. The position of the particle at time 3 is -5 plus our definite integral, which we determine to be -1.760. That's the position. That's all we needed. They awarded 1 point for the expression integral from 0 to 3 v of t dt, just for writing that down. 1 point for the use of the initial condition, either x of 0 or -5. So 1 point for the integral, 1 point for the initial condition, and then 1 point for your final answer, for a grand total of 3 points. Not bad. We've just picked up 4 points, and your calculator has been the thing doing all of the work. You need to have these core bits of information about acceleration and how it relates to the velocity, position and how it relates to the velocity, and the fundamental theorem of calculus. So you need those calculus concepts, but your calculator is really doing all the heavy lifting here. Let's keep going. In part C, we're asked to evaluate the integral from 0 to 5 of v of t dt and evaluate the integral from 0 to 3.5 of the absolute value of v of t dt and interpret the meaning of each integral in the context of the problem. Okay? So we need the integral from 0 to 3.5 v of t dt and the integral from 0 to 3.5 of the absolute value of v of t dt. Depending on your comfort with physics, you already know what these values mean. But let's figure out what the numerical answers are, and then we'll come back. Again, we're going to go to the calculator. And I'm going to menu, calculus, numerical integral from 0 to 3.5. The function is v of t, but on my calculator, it's f1 of x. We get 2.8439. That's correct. This next one's a little trickier. You're going to go to menu, calculus, numerical integral from 0 to 3.5. The function is the same, but you need to find the absolute value of the function. To find the absolute value, you're going to go over here to your templates button. You're going to select absolute value, which is in the second row. There are the absolute value bars. f1 of x dx. And for that one, we're getting 3.737. So let's go back. The first one, the value was 2.8439. 2.844 is going to be acceptable here. The second one is 3.737. What this means, the integral from 0 to 3.5 of the velocity function represents the displacement of the particle. Displacement of the particle from t equals 0 to t equals 3.5. The integral of the velocity function is your displacement. The integral of the absolute value of the velocity is the total distance traveled. So total distance traveled by the particle from t equals 0 to t equals 3.5. In terms of how they awarded points, coming up with both numerical answers earns you the first point. You have to get both of these answers correct to earn the first point. And then there is 1 point over here for the displacement. You have to say displacement. You have to say on the time interval 0 to 3.5. And then a third point for total distance traveled, again on the given interval, for a grand total of 3 points. Not so bad. This has been a kind question so far. We've already had the potential to pick up 7 points. All right, let's look at the last part, which is part D. All right, part D. A second particle moves along the x-axis with position given by x sub 2 of t equals t squared minus t for the time interval 0 to 3.5. At what time are the two particles moving with the same velocity? Now this is where the College Board stops being so kind. One of the things that they have started to do, and this has become pretty typical lately, is they talk about two different particles moving, or it's like a cat and a dog moving. It's two different objects, and you've got to consider what's happening with both of these objects. So in this case, they introduce a second particle, and they say that its position is given by t squared minus t for the time interval 0 to 3.5. Okay. This represents the position of the second particle, and the question is asking, at what time are the two particles moving with the same velocity? We already have a velocity expression for the first particle. Sorry, that's up a little high and you can't see it. We have a velocity expression for the first particle. We need a velocity expression for the second particle. So we're going to find the derivative. We're going to call this v sub 2 of t. Well, the derivative over here, not too bad, just use your power rule, is 2t minus 1. This is the velocity of the second particle. This guy up here is the velocity of the first particle. What we're looking for is at what point, at what time will the particles be moving with the same velocity. So what I need for 2t minus 1, the velocity of the second particle, to be equal to 10 times the sine of 0.4 t squared over t squared minus t plus 3. Now I've got to tell you, I have a master's degree in mathematics. I don't think I could solve this equation by hand. Well, that's okay, because we already have this, the right-hand side graphed on the calculator. We have 2t minus 1. I want to figure out where these two functions are equal to each other. What we're going to do is we're going to go back to the calculator. We're going to go back to the graph. Here's my velocity expression for the first particle. I'm going to enter, hello, what's going on? I want to enter the velocity expression for the second particle. And I'm looking for where on the interval 0 to 3.5 these velocities are the same. That's your point of intersection. So I'm going to go to Menu, Analyze Graph, Intersection, little to the left, little to the right, and the intersection point is at 1.571, comma 2.141. I want to know the time, so that's the x-coordinate, where the velocities are equal to each other. The time is 1.571. The common velocity for both particles is 2.141. The answer is going to be 1.571. So write that down on your paper. So T is approximately 1.571. That's it. That's what we wanted to know. Here's how they awarded points. They awarded 1 point for setting the two velocities equal to each other, and 1 point for figuring out the correct time where that happens. That is a total of 2 points. And that wraps up question number 2, calculator active. Not too bad. I hope that this was a high scoring question for you. And this is the kind of question I would expect to see on your free response exam this year. All right, good luck.